Here, differentiation of inverse trig functions. Here we are having an example here, being given y is equal to sine inverse of x, then y is equal to tan inverse of x, and last y is equal to cos inverse of x. How do you differentiate an inverse in what? In a trig functions. I'm going to do this and this, then we'll do this one. Yeah. Solution. Sine y is equal to sine inverse of x. Yeah, you have to first reverse this by making our x here the subject. You reverse it here. It will be x is equal to sine y. Yeah, we are going to differentiate sine. That will be dx here, dx dy. I'm saying dx dy because we are in this sine is in terms of y. That will be, if you differentiate sine, you'll get cos y, isn't it? Then from our trig identities, I now remember cos squared y plus sine squared y is equal to 1. But in this case, we are going to make cos the subject. That simply means it will be cos squared y equal to 1 minus sine squared y. But in order to get this, I have to introduce square on both sides, like this, so that this square will go with this root. Therefore, we shall be having cos y is equal to root 1 minus sine squared y as our cos y. From here, we are having x dx dy is equal to cos y. Yeah, but with parametric equations we shall be using it. Then we're going to find the reciprocal of this. Yeah, it will be dy dx is equal to 1 over cos y. Yeah, if you substitute our cos y here is this. Yeah, that simply means dy dx will equal to 1 over root 1 minus sine squared y, isn't it? But from here, x is equal to sine y. Yeah, that means dy dx is equal to 1 over root 1 minus x. Yeah, but in this case it is squared. That means if you differentiate sine inverse of x, you will get 1 out of root 1 minus x squared. Yeah, that is it. Then our next question is y is equal to tan inverse of x. Same procedure as y is equal to tan y. If you differentiate, we have dx dy is equal to, if you differentiate tan, you'll get sec squared y. But you have to find the reciprocal of this. Dy dx will equal to 1 out of sec squared y. From this trig identity, 1 plus tan squared y is equal to sec squared y. This is also trigonometrical identity which we are going to use. Then in the first example we had to make cos the subject, but in this case x squared y is already a subject. It equals to 1 plus tan squared. Then you have to simply just substitute dy dx will equal to 1 out of 1 plus tan squared y. But from this step, the first step, x is equal to tan y. That simply means if you will have to just substitute in to say that 1 over 1 plus, where there is tan x, put x. But in this case, our x is squared. It will be x squared. Then if you, that simply means if you differentiate tan inverse of x, you simply get 1 out of 1 plus x squared. Yeah. The third example is for cos. What do you get if you differentiate cos inverse of x? Same procedures as I did for sin x. Yeah. Then let me do another x. You do it. Roman free is cos inverse of y of x is equal to y. You do this one. Yeah. Let us go on the other number. Yeah, you'll be able now to do this. If I change, let me give you an example here. Tan inverse of 3x. Yeah, if y is equal to tan inverse of 3x. Since now we know that if you differentiate tan inverse, you get this guy here. Simply you will not need to differentiate again to see what you get. Simply just say dy dx. I'm saying dy dx because y is in terms of x here. Will equal to, what do you get if you differentiate this? You got 1 over 1 plus x squared together. But in this case you multiply it with, when you differentiate, you have to do a product here of this angle. Altogether this one in the question, differentiate this member of x here, and you'll be able to get, and you replace this guy here, this thing, you replace it here. For simplicity, you just get it like that. That will simply means if you differentiate 3x, you get 3. That means 1 times this 3 over 1 plus half 3i to be 3x, but what? Squared. This is our x here. X here is 3, 3x here. That will simply be dy dx is equal to 3 out of 1 plus 9x squared. Isn't it? That is it. If